our yesterday's class. So guys, yesterday, yes, we have started discussing about introduction about Java. Like I gave you small basic idea about history about Java, like who developed Java, like what is the first browser, name of the browser which is created with the help of Java, and what is the first name of Java, what is the first extension of Java, like that, and different versions of Java also we have seen, like different version history we have already seen that. And then we have in yesterday's class important concept which we had covered is like what are the differences between C++, Java. Like we have already seen that, like C is developed by Dennis Richard, and C++ is developed by Barn Stroustrup, Java is developed by James Gosling, and different features like model, platform dependency, keywords, pre-processor directives, inheritance, pointers, all these particular concepts we had covered in our yesterday's class. And yesterday, like we have already seen that, so there are different types of applications are there, like console based applications, desktop applications, or standalone applications, and web based applications. And basically, as I told you, console based applications are completely like outdated. No new projects are working on these console based applications. When you're coming to desktop or standalone applications, yes, very few projects are going on in this, but pretty much damn sure freshers will not be, for freshers, these projects pretty much damn sure will not be allocated. Okay, so after that, web-based applications, yes, right now all the projects which were ongoing projects, or else new projects which were going on, all those are concentrating on these web-based applications. So I told you this particular concept also. Right. So let us continue with our next concept, that is today's concept. So guys, when you are speaking about editions of Java, EDITONS, editions of Java, when you are speaking about editions of Java, basically there are three editions of Java are there, guys. Three editions. What are those? First one is J2 SE. Second one is J2 EE. Third one is J2 ME. Now, before going to this, guys, did you write the notes which I have uploaded yesterday in your notebooks? Did you write the notes? Guys, please make it as a habit. Please make it as a habit to write the notes in your notebooks. Okay, I'm requesting you, please make it as a habit. Every day, once my session is completed, I'll be trying to upload the notes every day. I'll be uploading it. Please don't neglect, please. Okay, I know, like okay, you guys are busy, I know that, and once our session is completed, our time will be like almost 9:15, 9:30. It will be coming like that, but I know. So please find a time, and try to write the notes, guys. Okay, all right, guys. Now, so yes, editions of Java, right? So guys, when we are speaking about editions of Java, I told you there are like three types of editions are there, like J2 SE, that is Java 2 standard edition. J2 SE means Java 2 standard edition. J2 EE means Java 2 enterprise edition. J2 ME means Java 2 micro edition. Okay, Java 2 standard edition, Java 2 enterprise edition, and Java 2 micro edition. In Java 2 standard edition, all the core Java concepts will be covered here. In Java 2 standard edition. What is actually Java to standard edition means? Java to standard edition, all the core Java concepts will be covered. Like whatever the concepts which we are trying to discuss in core Java will be covered under Java to standard edition. When we are speaking about Java to Enterprise Edition, we will be using this Java to Enterprise Edition for creating web-based applications. So advanced Java concepts will be covered. Guys, did you remember how many topics are there in advanced Java? Exactly. Very good, Tarun. Very good. I told you three. Yes, Tarun, Sridhar, Upendra, Krishna. Good. Three. What are those? JDBC, servlets, and JSPs. All those concepts will be covered under advanced Java, like Java 2 double E. And when you're coming to Java 2 micro edition, that is Java 2 ME, guys, this edition is used for creating applications for mobile computing devices. When I'm saying like mobile computing devices, please don't think like mobile phones. No. Mobile computing devices means the computing devices which you can transfer, like which you can take from one place to another place. That can be laptop, tablet, phablet, mobile phone, like that. Okay, so when you're coming to Java to ME, guys, this varies between one individual to another individual, right? So this varies, but as of now, guys, in our classes, as of now, which version of Java we are learning right now? Right now, which version of Java we are using? Like which edition? I'm sorry, which edition of Java we are using? We are using Java 2 SE, Java 2 standard edition. Is it clear, guys, for everyone? Right. Okay, yeah, that depends, Krishna, that depends. Okay, now, so guys, let me ask you a small question. I want to ask you a small question. Let me remove this. Now, now. So guys, package. When I'm speaking about package, tell me one thing. Inside a package, can I write classes? Can I write interfaces? Enum? Yeah, these are basic Java programming elements. We can write that. Okay, that is great. That is great. Inside a package, I can write class. I can write interface. I can write interface, and I can write enum. I can write enum. Okay. So yes, fine. No problem. Guys, one more time I am saying you, if you are asking a concept which is like, if you're asking a question which is not related to the concept which is going on right now in the class, I will not respond. Am I clear with this? I'm literally saying you. Why? Because the topic will be disturbed. If you are having a questions, you can ask me. Like once the session is completed, you can ask me. For example, Parvesh, you are asking, sir, please tell me I'm confused. Can we learn Spring Boot in advanced Java? I cannot answer that question, Parvesh. Our entire class will be disturbed. I hope you are understanding me. Please wait until the session is completed, buddy. Okay, guys, is it okay for everyone? Is it okay for everyone, guys? Yes. That is good. That is good. All right, guys. All right. Now. So, guys, as I'm saying, when we are speaking about a package, yes, inside a package, we can have classes, interfaces, and enums. That is very good. That is very good. Guys, inside a class, can I write variables? Yep. I can write variables. Inside a class, I can write variables. Can I write methods? Yeah, why not? I can write methods. Inside a method, can I write variables? Inside a method, can I write variables? Yeah, why not? I can write. Now, guys, just like a class, in interface, guys, up to now, I did not discuss anything about interface or enum. Up to now, in these demo classes, whatever the programs or else examples which we have done, all those are related to Java class only. And regarding interfaces and enums also, we'll be discussing that. Okay. But as of now, what I want to say is in interface, we can write variables. Okay. No problem. VARIA variables. And in interface, we can write methods. But in interface, every method is a abstract method. What I want to say is in interface, every method is a abstract method. Sir, what is a abstract method? Right. So guys, as of now, kindly please do remember one thing. Abstract methods does not have method body. Abstract methods does not have method body. For example, guys, what is the syntax of a method? First, we will be writing access modifier, access modifier. First, we'll be writing access modifier. After that, what will be writing? A return type, RETURN, return type. After that, method name, parenthesis, open braces and close braces. This is the syntax of a method, right? Now, I'm going to write the syntax of an abstract method. First, we will be writing access modifier, right? After that, I will be writing abstract keyword, keyword. Okay. And after that, I'll be using, I need to write a return type. Method name, and after that, I'll be writing semicolon. Like this. Now, what I want you to like observe is, guys, this is normal syntax of a method. I mean, normal syntax. Up to now, you know, if I ask you what is the syntax of a method, you will be saying like this. So inside this parenthesis, we will be writing method body or method functionality. Am I right or wrong? Yes, guys? Yes. So this is actually the normal syntax of a method. Now, when we are speaking about abstract method, guys, observe one thing. Can you please tell me what is the difference between normal method and abstract method syntax? Is there anything missing? Is there anything missing in abstract method? Yes, sir. Where is the body? Exactly, guys. Abstract method does not have any body. So, guys, normal question. I believe you can answer this. For an abstract method, Or inside an abstract method, can I write a variable? Inside an abstract method, can I write a variable? Exactly. Exactly. I cannot write variable. Why? Sir, without a body, how can I write a variable inside a method? That is exactly what I want to say, guys. That is exactly what I want to say. Guys, can you please observe this slide for me? Please observe this. When you are taking a package, inside a package, we can have classes, we can have interfaces, we can have enum. Inside a class, we can write variables, methods. Inside the method also, we can write variables. When you are speaking about an interface, we can write variables, we can write methods. Guys, what I told you, in interface, every method is by default abstract method. More information about interfaces we will be discussing whenever I'm dealing with OOPS features. As of now, kindly please do remember like this. Pratyusha, okay? More information. I will be giving you more information. Not right now, Pratyusha. Is it clear? Please tell me. Why? Because if I'm going on, like if I'm trying to go with one more thing, then that would be something different. Not right now. Okay. But for your answer, we can do like that also, like for question. Okay. Right. All right, guys. So what I'm trying to say is, inside an interface, we can write variables, we can write methods, but we cannot write variables inside abstract methods. Why? What is your like opinion, guys? Why we cannot write? Tell me why we cannot write. Exactly. For abstract method, there is no method body. Okay. Please kindly do remember this point, guys. And when you're coming to enum, just like a class, we can write variables, we can write methods, and we can write variables also like inside these methods. And these are the syntax of class, syntax of interface, and syntax of an enum. Guys, can you please have this diagram for me? Please. Somnath, yes. Yes, Somnath. Guys, how many Java language keywords are there? Did you remember? 50. All those 50 Java language keywords starts with small letter. Class is a keyword. Interface is a keyword. Enum is a keyword. So they will start with small letters. Don't forget that, please. Please note down and inform me, guys. Please inform me if it is completed. I'll be waiting. And guys, I requested you, please, I know you are listening from your homes. Yeah, but please create a proper environment, guys. I'm requesting you. Okay. Don't sleep and listen. Please don't sleep and listen. Just sit in a proper gesture. Please sit in a proper gesture and get ready with a pen and a paper, like pen and a book, right? Please. Shrikant, we'll be using those versions only. We'll not be converting them. Once we have created a project in a particular version, we'll not be converting the entire project in a new version. We'll be maintaining that project in the same version only. Okay, Shrikant. And guys, I told you like I'll be trying to give you day 8 recording, but actually as of now, I did not got that recording. So once I got that day 8 recording, I'll try to send you. Okay. Wait for it. Krishna Gupta, wait for it, please. Right. All right, guys. I hope it's completed for everyone. Is it done? Right. So guys, I hope it's completed. I hope it's no. Okay. One more minute. One more minute. Please go ahead. One more minute. Be on time to the class. Be on time to the class, please. By 8:05, only one, like 50 students have logged in. Still 50 to 60 students are yet to be logged in. So please log in on time, guys. Log in on time. Okay. I don't want you guys to skip, please. All right. I hope it's complete for everyone. I hope it's complete for everyone. All right. I'm removing this. Okay. Right. Next side heading as, guys, please write the side heading. Understanding JVM. Understanding JVM. Understanding JVM. That is actually a small side heading. Now, small question. Just like a small question. Just a second. Right. Now, question. Right. Now, what happens internally if we are, what happens internally if we are compiling and running a Java program? What happens internally if we are compiling and running a Java program? Guys, actually, we have already covered this particular point in our demo sessions. Let me try to say this. Please observe the answer. Just observe the answer. Okay. Now, if we are compiling our Java program with the help of the command javac space filename.java, comma, Java compiler is going to check whether we have written our program according to the Java language syntax or not. If we are compiling our Java program. What do you mean by compiling, guys? What do you mean by compiling? Compiling means checking whether we have written our Java program according to the Java language syntax or not. If we are compiling our Java program with the help of the command javac, the command. What is the command for compilation? Javac space javac space file name dot java. This is the command for compilation. That is a command for compilation. Javac space file name dot java. Java compiler is going to check whether we have written our program according to the Java language syntax or not. After successful compilation, Java compiler will generate a dot class file which consists of bytecode instructions which are understandable only by the machine. In our scenario, that machine is Java virtual machine. After successful compilation, Java compiler will generate a dot class file which consists of bytecode instructions, which are understandable only by the machine. In our scenario, that machine is Java virtual machine. In our scenario, that machine is Java virtual machine. The generated dot class file name will be name of the just a second. The generated dot class file name will be having same name as class name. The generated dot class file name will be having same name as class name. Okay, now we need to provide this generated dot class file as an input to the machine, that is JVM. With the help of a command Java space generated dot class file name, we need to provide this generated dot class file as an input to the machine, that is JVM. With the help of a command Java space generated dot class file name. This is the command for running. We need to provide this generated dot class file as an input to the machine, that is JVM, with the help of a command Java space generated dot class file name, which is the command for running a Java program. Which is the command for running a Java program. JVM is going to check whether all the bytecode instructions are correct or wrong. If they are correct, we will be getting our output. If they are wrong, we will be getting an runtime error. That's it. JVM is going to check whether all the bytecode instructions are correct or wrong. If they are correct, we will be getting our output. If they are wrong, we will be getting an runtime error. That's it, guys. Okay, guys, actually, we have already covered this particular point. We have already covered this particular concept whenever we are dealing with our demo classes. Is it clear for everyone? Can you please respond? Is it clear for everyone, guys? Now, in this particular concept, most important point which you need to concentrate is this one. The generated dot class file name will be having same name as class name. One more time, I am saying you, the generated dot class file name will be having same name as class name. Whatever your class is having, the same name will be there for the generated dot class file name. Okay, right. Now, guys, actually JVM is supposed to check those bytecode instructions, whether those are right or wrong. Kamlesh, without checking the bytecode instructions, we will not be getting the output. I mean, machine does not know, right? So it is supposed to check that. Okay. Now, guys, one important point which you need to remember is Java. When you're speaking about Java, guys, when you are speaking about Java, tell me, Java is platform dependent or independent? Tell me. Platform dependent or independent? Java is platform independent. Independent. Yes, Java is platform independent. Now, when you're speaking about JVM, this is interesting. When you are speaking about JVM, guys, kindly please do remember JVM is platform dependent. What? Yes, JVM is platform dependent. Sir, how Java will be platform independent and JVM is platform dependent? I did not understand that. Okay, guys, let me give you a very small, simple example. Let us think that I'm having an Android phone. Okay, I am having an Android mobile. You guys are having iPhone. Okay, both mobiles hardware is different. Am I right or wrong? Hardware is different, software is different, OS is different, completely different. Am I right? Now, if I send a message from my Android mobile in your iPhone, can you view that message? Yes. Why not? Even though the machines are different, like hardware is different, but they are able to understand the communication language. Am I right or wrong? In the same manner, guys, exactly in the same manner, when you are speaking about JVM, for example, guys, please observe here. We are having a Java file. After this Java file gone through the compilation phase, after successful compilation, what will be generated? A dot class file will be generated. After successful compilation, a dot class file will be generated. Now, this dot class file we can execute in Windows JVM, Linux JVM, Solaris JVM. in our simple language, I can execute this dot class file in Windows operating system. I can execute this dot class file in Linux operating system. I can execute this dot class file in Mac also. Windows operating system will be having Windows JVM. Linux operating system will be having Linux JVM. Mac will be having Solaris JVM. Are you able to understand what is happening here, guys? Each JVM is different. Guys, that is a machine, virtual machine. So basing upon the operating system, JVM will be different. Pretty much damn sure it will differ. But Windows JVM is able to understand the dot class file instructions, like bytecode instructions, which are present in the dot class file. Linux JVM will be able to understand the bytecode instructions which are present in this dot class file. In the same manner, Solaris also will be able to understand the bytecode instructions which are present in the dot class file. So Java is platform independent. But when you're coming to JVM, JVM is platform dependent. Guys, am I clear with this? Am I clear with this? Yes, Harshini. Yes. That is good, guys. That is good. That is good. Okay, just let me try to remove this. Right. Okay. Now, guys, do me a favor. Can you please keep your side heading as internal architecture of JVM? Please keep your side heading as internal architecture of JVM. Please. In the meantime, let me save this. Today's date is 5th February, right? Okay. Please keep your side heading as internal architecture of JVM. Guys, one more time I'm saying you, JVM is platform dependent. For every operating system, we will be having its own specific JVM. Kamlesh, I gave an example. Already, for example, when you're speaking about Android and Mac, like Android mobile and iPhone, why hardware is different? Tell me, Kamlesh. Basing upon its requirement, they will change. As simple as this, buddy. Okay. Yes, 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 yes. Now, please keep us reading as internal architecture of JVM. Okay. Just let me try to close this. Let me open it again. No, guys, do me a favor. Can you please have this diagram? Please have this diagram right now, right now, right now. Please have this diagram in your notes, please. Internal architecture of JVM, please. Please be fast. And guys, please inform if completed. Wait for it, Shrikant. Please wait for it. Send me that file, Shrikant. Like, what is the problem you're facing? Send me the file. 1 minute, guys. 1 minute. 1 minute. Just 1 minute, please. Go ahead. Inform me. Inform if completed. Guys, still some people are not writing. I told you guys, literally, I'm requesting you, please understand why I'm saying. Okay, write the notes. Write the notes. Please don't think like, sir will say like that only. Who will write? Please don't think like that here. Please. All my efforts are to bring the hidden genius out. That's it. So please write the notes. Write it. And again, I'm saying, don't sleep and listen. Don't sleep and listen. Please sit properly. Arrange in a proper gesture, please. Arrange a proper environment. All right, guys. All right. All right. So I think you have completed. Right now, just let me try to keep like a internal architecture of JVM. Just okay. Yeah, that's it. Internal architecture of JVM. Now, guys, I need 15 to 20 minutes of your time right now. So kindly please concentrate correctly. Okay. 15, 20 minutes of time, not more than that. Please, please. Right. Now, so guys, when we are discussing about internal architecture of JVM, the first concept which we are supposed to have an idea is about class LOADER, class loader. Okay. Yep. We'll be discussing about that class loader. After that, in JVM, guys, in JVM, we will be having 5 memory areas. Class area, heap area, class area, heap area, stack area, PC registers, native method stack, PC registers, native method stack, like that. After that, we'll be having execution engine, execution engine. We'll be having a concept that is execution engine. Now, inside this execution engine, we'll be having interpreter. Just let me try to get it like this. Just a second. Just a second. Just a second. Interpreter. Yes, that would be great. We'll be having an interpreter, and after that, we'll be having garbage collector. We'll be having garbage collector. interpreter and garbage collector. Garbage collector like this. Okay. So just a second. Like this. Okay. Sir, spelling mistake in stack area. What? Oh, okay. I'm sorry, guys. It's a small typo. Please don't mind. Typo. It's a small typo. Okay. Stack area. Yes, that is great. That is great. Okay. So right now, first, let us try to have an idea about class loader, guys. Okay. Now, class loader is going to perform three tasks. Three tasks. What are those? Loading, linking, and initialization. These are the three tasks which were performed by the class loader. First one is loading, second one is linking, and third one is initialization. Sir, what is actually loading, linking, and initialization? Yeah, I'll explain. Guys, now answer my question. If we want to see the output of our Java program, how many operations we need to perform? Two operations. Yes, first one is compilation and second one is running. Yes, whenever we are compiling a Java program with the help of a command javac space filename.java, after successful compilation, a dot class file will be generated. Yep, we know that. Now, this generated dot class file, we are supposed to provide as an input to the JVM. Whenever we are providing the command java space generated dot class file, first this dot class file, whatever the dot class file, like what is the file which consists of these bytecode instructions, first this dot class file will be loaded into the class loader. First, that dot class file will be loaded into the class loader. From the class loader, it will be coming to the JVM. Class loader is the first component in JVM. Am I clear with this? First, the dot class file will be loaded into the class loader. Class loader is the first component in the JVM. Now, linking. Okay, guys. Okay. Now, for example, guys, let me just try to ask you a small question. Okay, void method one. Void method one. Okay, now system.out.println, and here I'm writing hi like this. Simple statement, hi. That's it. Not more than that. Okay. Now, my question is very, very simple. Can I access method one in class B? Can I access method one in class B? Yeah, of course, I can access. Okay. If I can access method one, can you please tell me first what I need to write? Tell me. First, write. No, guys, not import statement. Guys, come on. We need to use import statement only if two classes are present in two different packages. Class A and class B both are present in the same package. No need to use import statement. First step one is I need to write main method. That is the step one. Why? Because without writing main method, can we execute the program? Can we execute the program? No. So the first step one is write main method. Okay. What is step two? What is step two? We need to create an object. Okay. Which object? Class A object or class B object? Exactly. We need to create an object for class A. And after that, directly, I'm trying to call a method one like this. Right click, run as Java application, and I'm able to execute my output that is hi. Wow, that is nice. Now, my question is, guys, listen to my question correctly, understand it, then answer. Don't immediately answer the question, okay? Okay. Now, my question is, if I want to run this program, without the involvement of class A, can I run this program class B? Exactly. Anant, you need to concentrate more, please. Anant, literally I'm saying you need to concentrate more. No, I will not accept that. No. I've been observing that your answers, Anant. For most of your answers are getting wrong. See, guys, I will never bluff my students. I'll directly say what is the concept. Okay. So please concentrate, Anant. I'm expecting more from you. Okay. Please concentrate. You can do this. Trust me. Okay. Now, guys, my question is very, very simple. If I want to run this program, if class B is not available, can I run this program? Obviously, no, I cannot. Why? Because in order to run my program, I need to create an object for class A. So without class A, for example, okay, for example, I'm trying to create like this, an object. Why I'm getting an error like this? Because class AA is not available. If it is not available, we'll be getting an error. Are you understanding me, guys? So if we want to run class B is linked with class A. Am I right or wrong? Class B is linked with class A. Exactly. That linking is also taken care by the class loader. Means which class objects you are using in your program, which class objects you are creating in your program. That particular linking also will be managed by class loader. Are you understanding me, guys? Yes. Now, initialization. Okay, guys, in Java, we are having a concept known as static, static keyword. Okay. In Java, there is a concept known as static keyword. Okay. Literally very important concept, static keyword. So we can use this static keyword in three ways. A variable can be declared as static. A method can be declared as static and a block can be declared as static. Now, we'll be discussing about those static concepts very soon, most probably within below 1 week or 10 days. We'll be discussing about that, like what is a block, what is a static variable, what is a static method, all those particular concepts we'll be trying to discuss that below 10 days, below 10 days. Okay. But as of now, what I want you to remember is if a variable is declared as static, memory will be assigned for that static variable at the time of class loading, not at the time of running. For example, let me try to have class A here. Okay, class A. Now, if I'm trying to write int A equal to 10 like this, okay. Now, main method, right. Now, my question is, guys, very, very simple. When memory will be assigned for this variable? When, sir, whenever we are running this method. Am I right or wrong? Whenever we are running, not at the time of compilation. Guys, you know what is compilation? Compilation means checking whether we have written according to the Java language syntax or not. So the memory for these variables will be assigned at the time of running. But if we are having a static variable, memory will be assigned for the static variable not at the time of running. Before running, at the time of class loading only, memory will be assigned. Means static variables will be initialized at the time of class loading, and that initialization process will be taken care by the class loader. So what is this static variables? How these are initialized at the time of class loading? All these particular concepts we'll be trying to cover in our static variable, static method, and static block. I hope it's clear, guys. Yes? Now, one more time. How many operations are taken care by class loader? Class loader will perform 3 operations: loading, linking, and initialization. Loading means whenever we are running our Java program, first the dot class file will be loaded into the class loader, and then it will be going to the JVM. Linking in the sense, your Java program, whenever we are writing our Java program, if we are trying to use any other classes, means your class is linked with other classes. Which classes you are having link? So that linking also will be maintained by the class loader. Linking, guys, linking. For example, if you are trying to create an object, of class A in class B, right now class A and class B are linked. Anita, are you understanding, Tali? Anita, are you getting me? If you are trying to create an object for class A in class B, if you are trying to create an object for class A, where it is, class A in class B, right now, both these classes are linked. So that linking also will be maintained in by the class loader. Class loader. Okay. Now after that, initialization. Initialization. Initialization means for static variables. Just remember like this. Static variables, memory will be assigned at the time of class loading by the class loader. Initialization will be taken care. Initialization means providing the value for the static variables. That particular initialization will be taken care by the class loader. As simple as it is, not more than that. I hope it's clear, guys, for everyone. What are the like works of class loader? Now, class area. Guys, all these five are all these five are memory areas which are present in the JVM. All these five are memory areas which are present in the JVM. Means you'll be getting a question like this. How many memory areas are present in JVM? Five. Five memory areas are present in JVM. As simple as this. Okay. Class area, heap area, stack area, PC registers, and native method stack. Now, let us try to observe what will be stored inside this class area. Inside class area, metadata. Inside class area, let me write like this. Inside class area, data about the data. That is metadata about the class will be stored. Inside the class area, data about the data. That is metadata about the class will be stored. Sir, what is metadata? Guys, metadata means data about the data. Data about the data means, for example, guys, in our demo sessions, we have given, like I have given you a lengthy program. In that program, I asked you how many methods are there. You told like, sir, 5 normal methods and 1 main method. How many variables are there? How many objects you have created? Are you understanding me, guys? In a particular class, how many objects you have created, how many methods you have written, how many variables you have declared, all that information, that is data about the data. Complete information about that particular class will be stored inside class area. That's it, not more than that. Inside class area, data about the data will be stored. Now, heap area. Heap. Right. Now, guys, inside the heap area, this is literally very, very important. Guys, inside the heap area, all the Java objects will be stored. You know, like how to create an object. So guys, if we want to create an object, can you please tell me which keyword we are supposed to use? Which keyword we are supposed to use? Good. That is literally very good. New keyword. Yes, very good. Dhanlakshmi, yes, good. New keyword. Guys, whenever you are using new keyword, immediately an object will be created and stored inside which area? And stored inside heap area. all the Java objects will be stored inside heap area. Okay. Now, guys, I want you to kindly please remember one thing. Inside heap area, there is one more special memory known as string constant pool, that is SCP. String constant pool, that is SCP. I'll be asking you this question again when I'm dealing with string handling. Can you please remember and tell me at that time? Like when I'm dealing with string handling, I'm going to ask you a question. Guys, inside a heap area, is there any special memory? I'm going to ask, same question I'm going to ask you. What is your answer? What is your answer? Inside heap memory, there is one more special memory. One more time I'm saying you, inside heap memory, for example, if you are thinking like this is heap memory, there is one more special memory. Yes, if you're thinking that that is heap memory, there is one more special memory inside heap memory, that is known as SCP. SCP. What is SCP? SCP means string constant pool. String constant pool. Sir, what is actually that string constant pool? Wait for it. Wait. We'll be discussing that. Okay. When I'm dealing with string handling, I'm going to ask you this. All right, guys. Right. Now, stack area. Okay. Guys, let me try to have a small program. Just a small program, literally very small program. Void some method, and here I'm just trying to create like int a equal to 10, int b equal to 20, int c equal to a plus b plus 10, like this, and system.out.println c. Oh, sorry. Order println C. Now, okay, main method. Now, inside my main method, okay, new class A dot sum method. I'm trying to call my sum method. Okay, so what is my output? Sir, come on, sir. This is a simple program, sir. We know that output, sir. Okay, guys, that is very good. Okay, now let me ask you a question. Where this 10 will be stored? Sir, this is actually a variable. 10 will be stored inside A. Yeah, that is good. Not in SCP. Okay. Sir, what about this 20? Sir, 20 also will be stored inside B. Yeah, that is good. What about this A plus B? Where this A plus B will be stored? Not C. Guys, in C, A plus B plus 10 will be stored. What is A plus B, guys? 30. 30 plus 10. This will be stored in C. My question is, where this 30 will be stored? Right. So, guys, one more time I'm saying you. Please listen to the point clearly. Please listen to the points clearly. Okay. Now, for example, let me, Preetham, can you please unmute? Preetham, unmute. Yes. Preetham, inside heap memory, what will be stored?
Inside heap memory, objects will be stored.
Exactly. Inside heap memory, objects will be stored. Is this an object, Pritham?
No, sir, this is variable.
Then why you are saying that the data will be stored inside heap memory? Are you understanding me, Pritham?
Yes, sir. Yes, sir.
Remember, Pritham, heap memory only for objects. Okay,
Yes, sir.
that is good. That is good. So, guys, not only Pritham, a lot of people gave me like an answer like heap memory. Heap memory is only for objects. Remember that. Now, guys, whenever we are executing a method, that method needs a temporary memory to store the data and results. Whenever we are executing a method, that method results a temporary memory to store the data and results. That temporary memory is allocated inside stack area. Harshini, is it clear, Dali? Yes, yes. Inside stack area, I am inside, just let me try to write like this. Inside STSEK stack area, temporary memory will be allocated to store the data and results. To store the data and results. As simple as this. Am I clear with this, guys? Is it clear for everyone? Yes, 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 yes. That is good. That is good. Now, registers. Sushil, yes, yes. Now, PC registers, right? So, guys, Java is actually in Java, we are having a concept known as multi-threading. What is the concept name? What is the concept name? Multi-threading. Guys, up to now, we did not came across that multi-threading concept, but we will be discussing that. Now, my question is, for example, let me try to have system.out.println, and here I'm just trying to write hi. Simply, I'm trying to write hi. Okay. Now, guys, when I'm trying to print hi, okay, right click, run as Java application like this. I'll be getting my output as like this. Okay. Guys, again, memory for the identifiers. Identifiers means like reference names, AOBJ, ABC, all these particular identifiers, memory will be assigned inside stack area only. Inside stack area only. Is it clear? Right. Okay, now please come back. Please get back. Now, guys, I'm trying to say up to now, guys, right. Now, up to now, what I'm trying to say here is, guys, we are discussing, like we did not discuss anything about multi-threading. My question is very, very simple. In my program, do I have any thread? Do I have any thread? No. Okay, sir. I don't know, like up to now. Why? Because we don't know what is a thread. Okay, I understand. I understand. Let me remove this. Right click, run as Java application. Can you please read the exception? Guys, can you please read the exception? Exception in thread. Now, do I have any threads in my program? Yes. Yes, there are threads. There are thread. What is the name of the thread, guys? What is the name of the thread? The name of the thread is main. Sir, but that is actually a method. Guys, as of now, kindly please do remember, main method is also considered as a thread. Thread. Okay. You can, I mean, up to now, we did not discuss anything about threads. What I want you to remember is a method can be considered as a thread. Just remember like that. Okay. Now, guys, in our demo sessions, we have taken a lot of methods. At a particular point of time, our compiler is presented which method, which thread. At a particular point of time, our compiler is presented which method or that complete log file will be maintained in PC registers. PC means program counter register. Guys, for example, we are having attendance register. Attendance register is there. In attendance register, what will be maintained? Like login time, log off time will be maintained. Am I right or wrong, guys? A register, normal register. Okay. Just like that, in program counter registers, in this particular memory, at a particular point of time, which method is getting executed, which thread is getting executed, completely a log file will be maintained in this program counter registers. Just let me try to write like this. Just let me try to write like this. In PC registers, or else just let me try to write like this. Here at a particular point of time, which thread is executing complete log file will be maintained. At a particular point of time, which thread is executing like complete log file means which one will be maintained, like executing will be maintained in this inside this program counter registers. That's it. Now, what are native methods? Guys, if you want to understand this native method stack, we should be having an idea about which methods are known as native methods. Native methods. Guys, please listen to me carefully. Please listen to me carefully. The methods which are not written in Java, but those are used in Java. One more time. One more time. What are native methods? Guys, what are native methods? The methods which are not written in Java, not coded in Java, but those are used in Java. Those are known as native methods. Means, for example, guys, we are having some traditional programming languages like C and C++ is there. Okay. Some methods which are present in C and C++ also, we will be using in Java. Sir, what? Yes. Yes. Those methods are not written in Java. Yes. Some kind of libraries. Those are not written in Java, but we'll be using them in Java. Those methods are known as native methods. One more time. One more time. What are native methods? What are native methods? The methods which are not written in Java, but those are used in Java are known as native methods. All those native methods are present in all those. Yeah, Mukesh, very good. All those native methods are present in native method stack. All those native methods are present in native method stack. Now, guys, yesterday, did you remember, like I told you, when we are speaking, like whenever we want to create a desktop or standalone applications, we are supposed to use applets, AWTs and swings. I told you. Did you remember that? Please respond. Please respond. Right. Now, guys, almost all the methods which are present in these applets are not written in Java. Those are written in C and C++. Almost all the methods. Are you getting me, guys? Please respond. Please respond. Yes. Yes. Not exactly. Anant. No, 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 no. Right, right. Now, guys, just let me come back here. Yes. Native method stack. Inside native method stack. Inside native method stack. Just let me try to write like this. Inside this memory, all the native method libraries will be present. All the native method libraries will be present inside native method stack. That's it. Now, all these are 5 memory areas which are present in the JVM. Now, interpreter. Guys, what interpreter will be doing? Interpreter reads the bytecode instructions which are present in the, sorry, just a second. Okay. Just a second. Let me try to get it like this. Okay. What interpreter will be doing? It reads all the bytecode instructions. It reads all the bytecode instructions which are present in the where? Can you please tell me where these bytecode instructions will be present? Class loader, dot class file. Come on, guys. Dot class file. Nayak, Kritika Nayak. Forgot. Interpreter is a component which will read all the bytecode instructions which are present in the dot class file in a manner, in a sequential manner. Means step by step, it is going to read. Now, garbage collector. Guys, what garbage collector will be doing? It will destroy it will destroy all the unused or unreferenced objects from the where garbage no, not JVM. Come on, Parvesh. Which memory, Sudhakar? Which memory? It will destroy, not stack, Harshini. Where objects will be created? Exactly, will be created inside heap memory, HM. Okay, garbage collector will destroy all the unused or unreferenced objects from the heap memory. So regarding this garbage collector also, we will be having a separate session, guys. We'll be having nearly like 1.5 hour session will be there for understanding this garbage collector also. Okay, so I hope you guys got a clear idea about internal architecture of JVM. Okay, Pooja, are you there, Tali? Pooja, are you there? Right. Pooja, Tali, never think that your question is getting ignored. Okay, guys, in my class, for almost all the questions, I'll be trying to answer them. If your question is related to the topic, I may not be answering it immediately, but I will answer. Okay, you need to have a patience, Pooja. Why? Because I'll be having nearly 200 to 250 students will be there, like right now in this particular meeting. Okay, so what I want you to do is you need to wait. Okay, did you got your question cleared, Pooja? Did I answer that? I told you, na, A, B, and C, those are, see, you are busy in typing the message. You are not listening that. What I told you, guys, did I told that references, identifiers, where these will be stored? In which memory these will be stored? Exactly, stack. Then you need to wait for that, Pooja. Okay, Tali? Guys, this is for everyone. This is for everyone. If your question is related to the topic, I will answer. I'm not immediately, but I will answer. If it is, I mean, if I answer is related to the ongoing discussion, immediately I'm going to answer. Or else I will bring back that question. So kindly please wait for that, guys. Can you do that for me, please? Right. So guys, I hope you have understood our today's session. I hope you have enjoyed our session. So applets, Satya, applets are used to create like desktop applications, standalone applications. Right now, those are outdated, Satya. So we will not be using them. Applets got replaced with UI modules. Okay. Yes. All right, guys. So that's it, guys. That's it for today. We'll be trying to continue our sessions again by Monday. I hope you have enjoyed our session, and I'll be trying to upload this data in our Google Classroom also. Okay. Yeah, you can call that Anchal. You can call that. All right, guys. All right. No need to note down. Somnath, like I'll be uploading the data in our Google Classroom. No issues. Krishna Gupta, top down and bottoms up approach. Java is actually bottoms up approach. Like we'll be trying to start with main method, right? When you are going with C, that is actually top to bottom approach. Okay. How many classes we can create in package? Any number of classes. You need to install that Srinivas Reddy. You need to install that. I already like told you how to install and I gave you that link also. So please check that. If you're unable to do that, uninstall it completely and restart the process again. Please. Okay. Right. All right, guys. I hope you had enjoyed our today's session. Guys, I'll be trying to continue our session again by Monday. All right. Guys, this video will not be provided. No, that is not there. I already told you. That is not provided. Okay. All right, guys.